The very first slide, I know the workshop is called Meet the Industry Partners. Actually, to be completely transparent on this, BioNanoNet or BNN is not really industry, as we are non-profit. So we are a spin-off from a big research organization based in Graz in Austria. And we are beneficiary in many EU-funded projects. With some of you are also here now that we collaborate. Very nice to see you, at least virtually these days. And we also coordinate the BioNanoNet Association. So this is an association where we connect more than 60 different organizations that are somehow in this nanotechnology field active. And in this network, we also do bridge the research and the industry side. So we do have universities, research organizations, but also companies and SMEs within our network. So we as BNN also try to bridge research and industry. Yes, and to also promote the cooperation between the different organizations on these three topics. One prominent, health and safety. The next one, data and sustainability, and also enabling technologies. And our members in the association are from currently 13 different countries. So we started more as an Austrian network, but in the past years we did expand also internationally. So this very quickly, so that you know a little bit about BNN. And my talk today is about safety by design, important cornerstones on the way to the nano market. Actually, as you saw maybe in the program, it was supposed that my boss Andreas will give this talk, but he apologizes for not being here today, so I said I can jump in and give the talk. So it's a little off topic, not totally a nanomedical topic, but it can also contribute to nanomedical innovation. So as introduction, I decided to take this graphic where you can see what you need to achieve to have a really successfully commercialized product. So when you start with your nanotech-based product, for instance, you have to follow regulations and have a patent protection. Then you must ensure scalability and also reproducibility. Then usually in this whole nanotech field, it needs multidisciplinary research. And then important cornerstone is really the sufficient safety data to also build confidence now in the public and industry to get your products to the market. And usually when you do just a simple classic chemical risk assessment, the risk is defined by the ECHA, by European Chemicals Agency, as a multiplication of hazard and exposure. So you have to think if your materials do pose any risks to human health or also the environment. And then we also have to decide, okay, how great is the exposure to humans and the environment. But usually this classic chemical risk assessment you do at the end of your innovation phase, more or less, when you decided already which materials you use, how you want to have your process and for which product you aim. So usually this is something you do in the very end and you assess everything. And with this safety by design concept, it should be the other way around. So the challenge is that with technological innovations, you usually lag behind with regulation and also with suitable risk assessment tools, because if you work really with new materials, you don't know from the beginning if there are potential risks or not, and if the materials are hazardous or not. And to really reduce these uncertainties and minimize risks to humans, but also the environment, starting at the earliest possible phase in the innovation process, so at the beginning of the innovation phase already, is called this safety by design concept. And it should cover also the whole innovation value chain. So it's really that you address safety issues, or that you also potentially think about safety issues from the beginning and try to design them already out during the innovation phase, instead of doing the risk assessment at the very end when everything is already decided. So what is the added value if you apply this safety by design concept? So it's really about assessing different settings and options during the innovation process. Of course, this needs to be done in a close collaboration with the technical developers. Having the real clear aim to design materials, processes, and of course also the interim or final product as safe as possible, while keeping the technical requirements, complying also to current and future regulations, and last but not least, keeping costs as low as possible. So this may sound easy and logical, but in the application, in innovation processes, it's quite complex actually. So for me, it's really to support innovation and not hinder it, and to find the best solution that you can have. So what do you need to consider? Of course, everything that is related to hazard exposure, health and safety issues, but also everything that is related to regulation, regulatory trends, because also, especially with, for instance, nanotechnology, the regulation is somehow moving, and it changes a little bit how you have to declare your products, for instance. Then we also have to consider the innovation itself and the related materials, processes, and products. And of course, also things like performance, costs, circular economy, recycling, and waste management. So it's really about balancing those topics and considering them from the beginning to really find the best solution. How can this look like in reality? Like, how can you implement it? For instance, on the materials level, you can think of substitution. For instance, use a different material that is less toxic or less hazardous, or modify your material, like coating it with something or modifying the surface whatsoever. Or if this is not possible, at least using less of it, so reduce it or have it maybe a more efficient process. For the processes, you can think of different settings, for instance, mode of operation, waste management, also recycling, energy consumption. And for products, you have to think about the consumer handling and if you can maybe optimize or improve it, end of life, so where does your product end, also waste, etc. And during these phases, considering potential hazard and also potential exposure, again, to humans and the environment. And considering the whole life cycle. So when you see here the process from nanomaterial production to the manufacturing, then you have a potential consumer use, which in nanomedical would be the patient. Up to disposal recycling and maybe back to manufacturing. You have to think about potential exposure to the worker in the workplace, of course for the patient when he is the consumer, but also altering steps to the environment. So especially now from nanopharmaceutical and nanomedical discipline, I think everything that is related to safety to the patient usually is well covered. But the whole concept is not only about the final product, but also about the whole process, how to get there, and then also about the environment, what you do with the waste, etc., and how you can optimize everything there. Of course, you also have limits when you want to implement this concept. As I said before, I mean, your performance parameters that you want to achieve are somehow a limit. So it's not the aim that the Safe by Design concept like completely hinders your innovation. Then, of course, the technical feasibility and the upscaling scenarios are sort of boundaries or limits that you have. The costs, of course, because also for industry, it's very important to have everything with low costs, otherwise it will not work out. And you have to also think about your workflow, the life cycle, and the system boundaries. So, for instance, in a project, okay, where do we start? What are the steps and who is responsible within the project, and what's really the target aim endpoint of the specific project. We do collaborate with many partners in different projects on this Safety by Design concept. So we are partners in several projects where specifically the concept itself is refined. So there are development of tools and indicators that are suitable for nano innovation. also for nanomedical or nanopharmaceutical innovation. And we are also project partners in application-oriented projects where we contribute this as a horizontal topic to the whole project. So next-gen microfluidics, for instance, is also an open innovation testbed focused on microfluidics, and we contribute with this Safe by Design concept. And we're also part of Phoenix, of course, that is not here on the list, but Nasende knows that we also collaborate there. And just a quick outlook. There is this movement on European level that now also sustainability is a hot topic and integrated into the Safety by Design concept. So I guess you all know that for sustainability, it's about these 3 dimensions you have to consider. So people, planet, and profit. So you have to really address societal, environmental, and economic aspects. It's, as I said, one of the hot topics right now, also for Horizon Europe and for the EU Chemical Strategy for Sustainability, for instance. We also have these well-known UN Sustainable Development Goals, which are 17 in total, I think. And just to let you know that there is now this movement to expand the Safety by Design concept to a safe and sustainable by design concept, because if you implement Safety by Design, I think you already address specific aspects to also say this is more sustainable than if it's less safe. But sustainability, of course, it's a little broader, and you also have to address, for instance, these societal aspects that are not so much included in Safety by Design yet. So I already come to my take-home messages. Integrating safety aspects already in the design phase of a new technology supports innovative breakthroughs in all sectors, or at least that's the overall aim. And it really should support also to find the best solution from an early innovation phase on. And definitely for this topic, multidisciplinary cooperation is needed. And with this, I'm already at the end of my project, of my presentation. Sorry, it's a little late. And happy to take your questions if you have any.